Hi, and welcome to the math. What are you doing? How did you get into this? This is math. All right, so we've got a dancing zebra today for math with Mr. Douglas. This should be interesting. What are you doing? Okay, we need to ignore that. And today we're going to be focusing on the line of best fit. Yes, it is going to be an exciting, action-packed episode with our good friend here, Mr. Dancing Zebra. All right, let's get to it. Dancing mime zebras. Didn't see that one coming. All right, let's try and focus here. We're going to talk about line of best fit, which means we need to be thinking about lines. So y equals mx plus b. We're also going to be building on our knowledge of scatter plots. So remember, a scatter plot is basically where you have, a bunch of data. So here's some data. This is going to be like a positive correlation data. And now what we want to do is create a line that represents this data. Now obviously it can't represent every single option, but what we want to do is somehow draw a line that goes through most of the data, create an equation, and then we can actually use the equation. So we can actually use this equation to make some predictions. So that's the idea. So why do we want to do this? Because we want to be able to use data to make some inferences for the future. So for instance, let's just say we were given this as temperature and the number of people in, say, a room. And you can see basically as the number of people increases inside of a room, the temperature increases. And you can see the data, this is some data that we've just gathered, and some of the data is not completely arranged, but these are basically our ordered pairs. So remember this, on day 1, there was 280 people, and then the temperature was 20. So as the temperature goes up, you can see that there was more people. So maybe this is, I don't know, maybe this is just taking a look at what happens at a beach. I don't know. But we do know as the temperature increases, we can see some sort of increase in people. Now my question though is what happens when, say, the temperature is, I don't know, 50 degrees? How many people would we expect? Or maybe the opposite. What happens when the temperature is 0 degrees? How many people might we want to go and figure that out? So the first thing you need to go and do is you need to go and graph. And you can use different kinds of programs to go and do this. I would recommend Desmos. I think Desmos is an awesome kind of program to do. And once you've done that, you draw basically a line through most of the data. So you can see it doesn't go through all the points, but it goes through most of them. And then what you want to be doing is going and finding 2 points that are the closest to the line. That's usually what we want to try and do. So if you're taking a look at this, this point right there is really, really good. And that point is going to be 20, 280. That's the first point I would use. And then the other one, I would really like this one. Now this point here is the 32 and 420. So point 32 people, or 32 degrees and 420 people. Now, why do I want to do that? Because I need to go and create a line. And to create a line, you need a couple of things. You need to have an M, and you need a B. So the very first thing I want to go and do is figure out what my slope is. So don't forget, we're going to use x1 and y1, and then we're going to use x2 and y2. I'll make this look like a y. There we go. And because we're going to use that equation, m is equal to, y, the difference of y over the difference of x. So we're going to go and plug in all of our numbers there. So if we're going to do some math, we're going to go and get, our 420 minus 280 all over 32 minus 20. So that's what we're going to go and do. And I think I'm getting 140 over 12. So you get 140 over 12. And then you're going to want to go and simplify that. Again, you should always have your calculator handy. Calculators are awesome. So I'm just going to go and quickly punch this into my handy dandy calculator and divide that by 12. When we get, we basically get 35 over 3. So our M is going to be, where should I write this? Let's go and maybe get rid of this stuff right here. Our M would be 35 over 3. Now we need to go get our B value, so our B. So I'm going to go and plug this stuff into y equals mx plus b. So I'm going to choose one of these points. I like this point right here. So y is 280. So 280 is equal to m, which we just figured out is 35 over 3, times x, which is 20, and then plus b. Okay, so I'm going to go and use my calculator, and I'm going to go and figure all of that out. So now, as I've kind of alluded to, as we've gone through a lot of this stuff, I'm kind of expecting everybody to go and be able to do this quite nicely. So if I did all that, I would get B is equal to 140 over 3. 140 over 3 is B. Great. So now I have my M and I have my B. There's my M and there's my B. So now I can go and basically make an equation, and that equation is going to allow me to make predictions. So my final equation is y equals 35 over 3x plus 140 over 3. And in case you're wondering, 140 over 3 is about 46 2/3. So it's approximately 46 2/3. That's just kind of a fun thing to kind of know, because when we bring back, obviously, our stuff here, so that's what we're going to be getting out of this data. Now, if you chose different points, do you expect that you would get the exact same equation? Maybe, but probably not. So that begs the difference, or begs the question, is that okay? Well, yeah, when you're doing things by hand, that's going to happen. But obviously, we would use computers. And what they do is they kind of take the average of all the different possibilities, and they do this really funky calculating in the background. And then, poof, they give you the best possible line of best fit. So a website like Desmos would do that. But if you're doing this by hand, expect your equation to be a little bit different than the person beside you, unless you've chosen the exact same points near the line. So now that we have that, now we can go and do the real fun stuff. So what's the real fun stuff? Well, I'm glad that you asked. The real fun stuff, of course, is going and using that. So I think it was, what was it? It was going to be 35 over 3x plus 140 over 3. So now we can make our predictions. I want to know what happens when it's 0 degrees. So what is it going to happen when it's 0? I want to know how many people, when it's really cold outside, how many Canadians are still stuck around there, right? So if you do put 0 into this, if I put 0 into right here, so if I go and just kind of plug that in, think about it. What's 35 over 3 times 0? It's going to be 0. So then when it's 0, you're basically going to be left with 140 over 3. Which is about 46 2/3. And what does that mean in real life? Well, that means there's about 46 2/3 people. I don't know, maybe somebody is there and they are, I don't know, they're missing one arm and maybe one foot. I'm not quite sure. That's the 2/3 of a person. The person's still happy though. Yay, there he is. He's all happy. And that's what it would be basically. So that's interesting. Well, what happens when it's 50 degrees? What happens when the temperature has soared and is now 50 degrees? Well, again, I take my 50 and I plug that into there, and I would go and multiply my 35 over 3, and I would times it by 50, and then I would go and add 140 over 3. and I would get exactly, this is pretty cool, you would get exactly 630 people. 630 people would be expected at 50 degrees. Now, a really interesting thing, now this is kind of where stats gets kind of interesting. If it was 100 degrees, if it was a balmy 100 degrees, what would happen? We'll bring this back. So if it was 100 degrees, so if it was like, it was super sunny and it was 100 degrees, what would you expect? Here's my son. My son's awesome. There he is. He's happy. Maybe he's dancing with a zebra. I don't know. What would happen? How many people would you expect? Now, if you were like, oh, I'm just going to go and throw that into here and then just go see what happens. But that's what the mathematical answer would be. In reality, if it was 100 degrees, you would say, no, I'm not going outside. And there would be perhaps no one. So you do have to realize that there is the real life situations. And that's always a thing to kind of keep in mind when you're looking at stats. You also often have the mathematical, and then you have the actual reality of what will happen. So do kind of keep that in mind. So line of best fit. So again, we're trying to find the lines that best kind of go through your data, like that, and then making an equation to use that for predictions. Let's get back to some dancing zebras, shall we? All right, thanks for tuning in. Dancing with this guy. Hopefully you learned some good stuff here in Mathland. And until next time, be awesome.